All right, this is Chapter 6, Section 2, Solving Systems by Substitution. So when we're looking at substitution, the first thing we want to talk about is this word equal and same. When two things are equal, they have the same meaning. They mean the same thing. So my example here, 2 plus 5 and 6 plus 1, those two are equal. 2 plus 5 does equal 6 plus 1. And the reason they're equal is because they both are the same as 7. 2 plus 5 equals 7, and 6 plus 1 equals 7. So 2 plus 5 and 6 plus 1 have the same meaning. They both mean 7. So we can replace 7 with either one of those. And that doesn't seem like too complicated an idea, but this whole concept of equal and same is going to be a really big piece of solving systems by substitution. So the example I'm going to use for that is, if I have two equations, y equals 2x and y equals x plus 5. So we've got two equations, two unknowns. Now, the first thing I'm going to do, just to kind of show you a general idea of what we're talking about, is I'm going to take this y equals 2x, I'm just going to flip it around. So instead of y equals 2x, I'm going to write 2x equals y. I haven't really changed anything, I've just flipped it around. And if I slide this over, you'll see that since both 2x and x plus 5 equal y, really, if you can see it, 2x is going to equal x plus 5. Because that y, since they both equal the same thing, the 2x is going to have to be equal to x plus 5. You can almost jump that middle piece. So I'll split those apart again and talk about how with substitution it's the same idea, same equal. So 2x equals y. So wherever I see a y, I know that's the exact same as 2x. They mean the same thing. So I see a y right over here. So instead of y, I can replace that y with 2x because they're the same, they're equal. So instead of y equals x plus 5, I'm going to put 2x equals x plus 5. Now the reason I did that was because now I have an equation with only one letter, with only one variable. I can solve for x. So I'm going to do that now. I'm going to subtract x from both sides. And I'm going to get that 2x minus x equals x, and x equals 5. So I solved for x. I know what x is in this system of linear equations. Here's my arrow here. Now, since I know what x is, x equals 5, x is the same as 5. So wherever I see an x, I can put a 5. And look right up here, I've got an x. So instead of 2 times x equals y, I'm going to put 2 times 5 equals y. I'm substituting 5 for x, which makes it really easy to solve because 2 times 5 is 10. So I've used my two equations to eliminate one of the variables and solve for my x. Then I used x and substituted it back in to find y. And now my final answer for this system of linear equations is going to be an ordered pair x, y. 5, 10. The ordered pair 5, 10 is the solution for this system of linear equations. 2x equals y and y equals x plus 5. We'll do another example here. We've got my system of linear equations, y equals 5 minus 2x and y equals x minus 4. So I'm going to use this substitution method to solve for x and y. So I'm going to look at these two equations separately again. Pull them out here. All right. So I've got my two equations. Again, y equals x minus 4. So they mean the exact same thing. So wherever I see a y, I can substitute x minus 4 instead. And again, look right there, I got myself a y. So I'm going to put x minus 4 equals 5 minus 2x. Again, the reason I could do that is because x minus 4 and y have the same meaning. They're equal. Now I can solve for x. I'm going to subtract x from both sides. To get my x's all together, I've got negative 4 equals 5 minus 3x's. And finish it up here. We're going to subtract 5 from both sides. I'm going to get that negative 3x. Don't forget that minus sign stays with the 3x. It's going to equal negative 9. And then I'm going to divide both sides by negative 3. Forgive me, the board is not cooperating. And x is going to equal, remember, a negative divided by a negative ends up equaling a positive 3. So we solve for x. We have that x equals negative 3. Now I can use that x, and I can substitute it back in to that first equation, y equals x minus 4. So instead of y equals x minus 4, I'm going to have y equals positive 3 minus 4. So y is going to end up equaling negative 1. I'm going to write my solution as an ordered pair. The solution for this set of linear equations is going to be x, y, 3, negative 1. And that's how you use the substitution method for solving a system of linear equations. Okay?